Hello guys, in this video we'll be discussing LeetCode Weekly Contest 401. So let us dive into the first problem. So first problem statement says that you have to find a child who has the ball after k seconds. So what the problem statement states here we are having n and k, and we have to initially ball is at child 0, and he is passing that to the first child 1, child 2, and child 3, so on till child n minus 1. Afterwards, the ball direction is getting reversed. So at last, after k times, we have to find who the child number who is having the ball. So if you carefully observe, first child 0 is having the ball. Next, it goes to the first child. Next, second child. Afterwards, it goes to the first child, zeroth child, and at last it will be at the first child. So we have to return 1. Similarly, you can do the same thing for the next example. 0th child, first child, second, third, fourth, and it goes to the third child. At last it reaches to the second child. So you have to return 2. Here the constraints are very low, so we can go with the brute force approach. So what is the brute force approach? Let's say if you are traversing in the positive x direction, we'll add our position with +1. Similarly, if we are going in the reverse direction, we'll make our position with -1. That is in the negative direction, negative x direction. So in this way, we'll try to run it for k times, and we'll check what will be our answer after the k number of rotation, or we can say after k seconds. So what is the first step? First step here is we are iterating for k times, and first thing we'll be having position as 0, and direction will be in the positive direction. So let us make our position to 0. So position will be, so if position is greater than, what is your first thing? So if position is equals to 0, or position equals to n minus 1, then our direction will be reversed. Okay, so every time the direction will be reversed whenever position changes. At last we are going to return the last position wherever it stays after k seconds. So it has passed the sample cases, and we'll check for other test cases also. So it has passed for every test case. Now if you look at this problem, can we solve this problem without using for loop, without even iterating for k times? Is there any mathematical solution for this? If you look carefully, how till here it is, we are traversing till n minus 1. Let us consider n as 2 here, because we are moving from 0 to n minus 1 itself, and k is 5 here. So in total, how many rounds it has been completed completely? So we can say number of rounds completed completely are 5 by 2, that is 2. So first round in positive x direction, and second round in negative x direction, it has been completed. Now how many extra things it's traversed from positive x direction? How can we say that? So we can say by using modulus, right? Simply by using k mod n, we will be saying how many, we can easily say how much extra it has traversed from the negative to in the positive direction. So it has traversed 1 unit in the positive direction. So we can simply return 1. So it has completed 2 rounds. It has completed 2 rounds, and after completion of 2 rounds, in the sense it came to the original point, that is in the positive direction. It is moving in the positive direction. from the positive direction, it has moved 1 unit further. Now let us look for the second example. So if you look at the second example, n will be taking at 4, k is 6, and now we will be doing 6 by 4, it is 1. One round has been completed in the positive x direction, but while returning, how many rounds has been completed? Only 2 units it has moved in the negative x direction. So how can you say this position? So how can you say this simple position for this? So you'll be subtracting this from the, if now we'll be subtracting this from the n. So it will be simply like n minus extra. So is this extra? So to find this, we'll be having the entire n here. So this is the extra thing. So from starting, we have to find this index, right? So it will be like n minus extra. So we will try to simply code this solution. So we'll try to reset. If you reset it, first thing, we'll decrement our n. So if we decrement our n, the next thing we are trying to find is number of rounds. Number of rounds will be k by n, and how many extra rounds we are making, that will be k mod n. So if rounds percentile 2 equals to 0, we'll be returning what we are going to return. If you look at the example, we are going to return the extra, else we are going to return n minus extra. So this is a simple solution. So it has passed the sample test cases. Now we'll try to submit it. So these are the two approaches in which we can solve this problem. Now we'll move to the next problem. In this problem, you are given two integers n and k. Initially, you start with an array of n integers where each element is initialized to 1. So after each second, you simultaneously update the element with its preceding element plus that element itself. So if you look at the example, you'll be having much clear idea. So initially at the 0th second, you'll be having everything initialized with 1, that is t equals to 0. So when t equals to 1, instead of t, we can name it as k because it is given in the question. So k equals to 0, k equals to 1. It will be updating here. So in first element will be 1, and here it will be 2, here it will be 3, and 3 plus 1 will be 4. Similarly for k equals to 2, if you clearly look, first element will be 1. Here sum of 2 and 1, that will give you 3. 3 plus 3 gives 6, and 6 plus 4 gives 10. This is what said in the question. At last, after k seconds, that is at k equals to 5, you have to return the, if you declare this array with the prefix sum, something like that, pf, you have to return the pf of n minus. This is what the question meant. So one more thing mentioned in the question is your answer might be large. So whatever the array, if you are populating the array something like pf of I minus 1 plus pf of I, this value can be large. So he is asking you to apply the modulus. So if you know clearly the application of modulus, a plus b mod m, how can you write it? A mod m plus b mod m whole mod m. So this is a simple formula which we can apply and apply the modulus on addition of two numbers. So let us try to code this question. So first thing, you are declaring an array with pf, and here n, if you are having n numbers, so you are making size as n, and everything is initialized with 1 initially. So you are going to traverse it for k times. You are going to traverse it for k times, and j is traversing from 1 to j is traversing till n. As always, the first number, that is 0th index, everywhere is 1. So there is no need of traversing on that index. So we can simply say pf of j equals to pf of j mod plus pf of j minus 1 mod whole mod. So we did not initialize the mod, so we can initialize our mod with 1 in 9 plus 7. At last we can return pf of n minus 1. So if you run the code, it has passed for the sample test cases. Now I'll just try to submit it. So it has passed for all the test cases. So this is about the second question in the LeetCode weekly challenge. So in this problem, you are given an integer array, that is reward values of length n, representing values of rewards. So initially your reward is 0 and all the indices are unmarked. You have to perform the following operations. You can perform the following operations any number of times. So you have unmarked indices in the range of 0 to n minus 1. And the second condition is, that means we can pick any index in the given array, and reward values is greater than the current total reward, so that then only you can add that rewards value to that particular x and you can mark that index. So here the problem statement is, let's say you have marked first index, 0th index. So let's say it has 0, 1, 2 and 3. If you have marked index 0, that means your x is 1. Initially your x is 0. Now if you have marked index 0, it is 1. And you are going, let's say you are checking index 1. Before checking index 1, we will be checking whether x is greater than that index 1 or not. If it is just equals to, you are not going to check and mark it, then you will go to the index 2 as x, and values of I is greater than x, so you are going to mark it, and if you are marking it, your x becomes 4. Next, reverse value is still less than this x, so you are not going to mark it. So last one also you are not going to mark it, and your complete value here is x equals to 4. Now let us try to check. That means you are picking indices 0 and 2 in order, in this given order. Now let us look into this example. If you look into this example, if you are going in the same direction, let's say if you are marking 1, let's name these indices. So if you are marking 0th index, then your x will be 1, and as 6 is greater, you can add it, you can still mark it, so your x becomes 1 to 7. As 7 is greater than the given reward value, you cannot mark it, so everything you have to unmark. So you'll get answer as 7 when you pick 0 and 1 indices. But is this the maximum answer? No, right? So there was another way. So what was the other way? Marking. So other way was marking 0th index first, and it will be 1. And before marking first index, you can mark your second index. So second index, your value becomes 5, and after that you can mark the first index because 6 is greater than 5, so it becomes 11. Now we are marking first index. If you observe clearly, here we are not going in the particular order. That means we are not going in the given sequence. So if you clearly observe here, according to the given condition, reward value plus reward value must be greater than the current sum, previous sum, that is current sum. Then only you can add it. So intuition, if you clearly observe, we can sort the array. If you sort the array, then you can apply this logic very easily. So if you sort it, you can have the axis of the current sum, and you can check with the present index. If it is present index is greater than the current previous sum, that is current sum, then you can add it, and it becomes very much easier than the previous one. So in this case, you'll be having you'll be marking 0th index, first index, second index, third index, fourth index. Let's say if you are marking first index, your sum will be 1, your x will be 1, and you are marking 0th index, sorry, it is 0th index, and next you are marking first index, value x becomes 3, and next you are marking second index, value becomes 6. Now x is 6. As x is 6, can you actually add, can you really add 3 to this? Because as x was 3, you cannot add 3 to this, right? So what you can add? You can add 4. So instead of marking second, you will be marking third index. So if you mark third index, your value becomes 3 plus 4, 7. And can you mark fourth index again? No, you cannot mark fourth index again. So it is very much clear. Your sum will be 7 if you are going marking in this way. So what is the other way of marking? So mark first index, and mark after marking first 0th index, that means 0th index, and you can mark third index, then your value becomes 5, and then you can mark fourth index, your value becomes 11. This is a way which you can mark to get the maximum sum. So first thing you have observed, we have to sort the array. After sorting the array, we are just simply finding the maximum subsequent sum. So these problems, after sorting, it turns out to be the maximum subsequent sum, because in the given order we are avoiding, we can either pick some element or we cannot pick those elements. So we are following the order, but it may or may not be contiguous. So here maximum subsequence sum. This problem, after sorting, we have to find the maximum subsequence sum. So if you look at this problem, we can clearly say that if there are n elements, 0 to n minus 1, everything has two options. Either you can pick it, or you cannot not pick those elements. So total possibilities will be 2 power n, and this will definitely give you the TLE. So what is the other way of solving this problem? So first thing, when you are going to pick the element and when you are not picking the element. So for picking the element, definitely you will be maintaining some value. So current, whatever the array is there, that is, let us call it as nums. So in this problem, now let us call that vector as nums. So if the present index is greater than the value, that is current sum, then only you are going to pick it. Otherwise, you are not going to pick it. Yes, this is clear, right? So now let us try to verify, or let us try to check what are the variables required to solve this problem. What are the parameters required for the recursive call? So let's name that as helper function. So what are the things required? You'll require the index, definitely. Let us initialize that with 0. And what is the other thing? So definitely you need the sum, right? That is the current value, whatever the sum you are going to get whenever you are marking the index. And other thing is nums, and definitely you will be having other things like memoization, that is 2D. Definitely you'll be having other memoization, will be using memoization. That means which parameters are you depending upon? You are depending upon index, that is n plus 1. And what is the other thing you are depending upon? The value. So what can be the maximum possible sum value for this problem? What can be the maximum possible sum for this value? So maximum value here is 2000. So if let's say reward values is equals to 2000, if it is equals to 2000, if it is equals to 2000, when you are going to pick, when you are going to include this value, you are going to include this value if current, that is what are the parameter which we are given, that is value. If value is less than this, that means then only you are going to include this 2000. Otherwise there is no other case where you are going to include this 2000. And what must be the nearest value to this? It will be 1999. So even if you are going to include this, then what is the value you will be getting? It will be 3999. So 3999 in the sense, what can be the your vector size, what can be the size here? It can be maximum possible can be 4000. So you will initialize with n plus 1 and 4000. It is not that 2000, you should not declare your array size with 2000 into 2000, because it is not possible. Like it can't be 4 into 10 power 6. It will be giving you the, it will be giving you the TLE, TLE and MLE, and it is not required also. If you correctly, if you check those, what are the constraints given here carefully, you'll clearly observe you are going to include this 2000 if the value should be less than the 2000, then only you are going to include, and that value comes out to be 3999. This is the maximum possible thing, and that's the reason we have declared with 4000 here. So this is all about the parameters which you require. So you'll declare your helper function with 00 nums, and then you'll initialize, you'll call your index with 0 initially and value with 0, and then also you'll be having nums here. Now let us try to analyze the situation and analyze how the parameters of your helper is going to change whenever you pick it and whenever you not pick it. Whenever you pick it, your helper function, you'll increment your, definitely you'll be incrementing your idx. Yes, what happens to your value? What happens to your value? Your value becomes, your value becomes nums of idx plus value. And what is the other thing? Well, yeah, simply you'll be having your nums. And whenever you're not going to pick it, you'll be having a helper. And what is the parameter here? You'll be having idx plus 1. And as you are not including it, your value remains the same. And you will be having here as nums. So these are the recursive calls you are going to maintain. And after this is for inclusion and this is for exclusion. So you are going to consider the maximum of inclusion and exclusion, then only you are going to return 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 or store your present state in your given problem. So this is all about the explanation of the logic. So if you have understood the logic till here, try to pause the video and try to code on your own. Now let us think about the base conditions. So what can be the base conditions? Simply if idx is equals to n, you are going to return the value, current value, and you are going to memorize this solution, right? So whenever you are getting maximum value, you know the present state, that is idx, and what are the value is there. you are going to store the maximum of inclusion and exclusion. So all about this is all about the logic explanation. Now let us try to code this solution. So first thing, as we require this n and memorization, let us try to declare it globally to reduce the parameters of recursive function. So it is memo, and first and foremost you have to sort the array, given array. Then after sorting it, what is your next step? Your next step is to call the function, that is helper function. And what are the things you are going to follow? First, index, and next current value, that is value, and you can pass the reward values, that is given vector. After passing this, you'll be having helper function, and you'll be having index, and you'll be having value. Let's name this vector as nums. Now, first and foremost thing, what happens when we include whenever the inclusion happens? So definitely it can be val, even if it is included or not included, the value will be present. So when we are going to include it, nums of idx is greater than. If that value is greater than the given value, then you are going to include it. So what happens to your inclusion? For your inclusion, you are going to call the helper function, and it will be idx plus 1, and whatever the value you get, that will be nums of idx plus value. So you are increasing your value, and next you are calling your nums. So this is all about the value. Next thing, exclusion happens whenever exclusion happens, so you will still increment your idx, that is index, and but your value remains the same because we are not including it. What is the next important step? Your next important step is to, whenever we complete all these things, to we have to store the result of the present state. So you are storing the result. How do you store it? You will be storing the maximum of both inclusion and exclusion exclusion for it. Before that, we have to initialize our memo. So how do you initialize it? Memo will be vector int, that is 2D vector, and here you are going to make the size as n plus 1, initialize size with ring plus 1. And what is the maximum possible value for this? It is 3999, and so we have to initialize with 4000, and we are initializing with -1 here. Now this is all about initializing the memo. And what what if the present state result is already calculated? You will be simply checking whether it is equals to -1 or not. If it is not equals to -1, you will be simply returning that value instead of again computing it. So this will reduce your time complexity. Now, what is your base condition? And this is very important. If idx is n, what you are going to return? You are going to return your value. So whatever the value is there, that you are going to return. So this is all about the code. Let us try to check the code. And there has been compilation error something near line 18. So yeah, we have to use the return statement here. Yeah, it has passed sample cases. Now let us try to submit the code. Yeah, it has passed all the cases, other test cases. And now let us look into the time complexity for this code. So if you look at this code, it is simply depending what are the parameters it is depending upon, n, and what is the value, and this is nothing but the maximum sum, that is sum whatever the maximum sum possible. So it is n into sum. For n into sum, so what are the constraints for this problem? For n, it is 2000, and let's say for some it maximum possible value is 4000, and it is something like 6 into 10 power 3, 10 power 6. So this is the reason we are getting it as accepted. And what is the, this is time complexity. What about the space complexity? It is same, n into max sum, or you can say it as sum. So this is about the space and time complexity. Hope you have understood this solution. Thanks for watching the video. For more such content, subscribe Smart Interviews YouTube channel. Do share and like this video if you found it informative. Until next time, this is Karthik signing off.